today we're doing some machine learning testing. This is primarily to check out what the new M2 Pro and the M2 Max are capable of. We're going to be doing some training, and that's going to include the ResNet, MobileNet, DistilBERT, and BERT large models. These are going to utilize Metal, so these are going to be for the Max only. I will also be doing some TensorFlow inference, and this is going to include all the machines I have here, including this PC laptop. It's an Asus with a Ryzen 9, and it's got a 3070 in it. Also, something brand new is testing the Apple Neural Engine. Yes, we can now have an isolated test for that, and I'm going to be doing that in this video. So what machines do I have here? We've got the Asus, I already mentioned that one. This is my M1 Max MacBook Pro with 64 gigs of RAM. M2 Pro MacBook Pro with 16 gigs of RAM. We're going to see how the RAM plays into this, and the M2 Max with 64 gigs of RAM, and I'm gonna throw in the big boy back here, which is the M1 Ultra Mac Studio. We'll see how that does against the new hardware. First thing I'm gonna do is train some deep learning models, and this is based on this particular repository right here. This is by Timothy Liu. I'll link to it down below in case you want to run this yourself, and it's called TF Metal Experiments. So this is designed for running on Apple Silicon, and it's using TensorFlow. This particular experiment has 4 models that it tests using different batch sizes. ResNet 50, it's a 50-layer convolutional neural network. Then there's MobileNet V2. It's also a convolutional neural network, CNN. This one performs well on mobile devices. Then there's a couple of BERT-based models. BERT is the natural language processing model. There is one called DistilBERT. It's a small, fast, cheap, and light transformer. Then there's BERT Large that's also included here as well. So whereas BERT has 12 encoder layers, BERT Large has 24 layers. I did have a chat with a frequent commenter on this channel, Peter Lin, and he actually created one of the tests we're going to be running. He said that BERT, being a large language model, is very relevant to us right now.
Yeah, just because GPT is so popular now.
He said that typically if you want to run BERT models, you're going to need a lot of RAM. And if you want to try to do this on a MacBook Air that doesn't have cooling, well, here's what he said.
The interesting thing about large language models is, like, once you get into the billions of parameters, the amount of memory you need just kind of ludicrous.
What happens on a MacBook Air with like 16 gigs of RAM when it's running such a large model?
You can't. Typically, you have to shrink down. You have to prune GPT-2 to get to run on memory limited systems. That one had 80 billion parameters. So those are floats. You just do the math. If you want the full fat one, you have to get like Tesla V100 or something with 24 or 40 gigs of memory.
Might as well kick things off with this very first test. I've already set up my Conda environment. It allows you to basically have a separate dedicated environment for all your dependencies. I also have a video on setting up Conda. Check that one out if you want to see. All right, Python train benchmark. Let's go. Here it is running, and you can see that the GPU is being fully utilized. There's the memory pressure right there. This is right here the 16 gigabyte model that I'm using, the M2 Pro. And you can see that this is really getting into the swap pretty hard. Not ideal at all. So if you are going to be doing this, watch out. You're going to need to have a lot more memory than I have in this machine, which is 16 gigs. Okay, now the training started. We're running 3 epochs. So this is still utilizing the GPU fully and not using the ANE. To see the ANE usage, you have to use a tool called AziTop. I can show you that. As a matter of fact, AziTop was a tool created by Timothy Liu. What a coincidence. All right, so here's the ANE usage, 0 being used. There's the GPU usage. We're hopping up there. I have seen it hit 100% too. And we're seeing the power that's being used by the GPU as well right here. And this is the total power being used by everything in the SoC, in the SoC. And the fans finally kicked on. They're about 1400 RPM, and they're gonna stay on pretty much the whole time this is gonna be running. There's our result. We have samples per second, 68. So this is on the M2 Pro. There's one more thing I wanted to mention about the M2 Pro specifically. It does not have high power mode like the M2 Max and the M1 Max and the M1 Ultra. You can enable low power mode on the M2 Pro, but there is no option to do like high power mode on battery. Well, here, for example, we've got the M2 Max. I have those set to high all the time because I just don't see a need to set it to low. The options are low, automatic, or high. Same thing with the M1 Max. You can change those up, and that'll probably have an effect on the training, but I'm not gonna do that because why would you set it to low power? The batteries last long enough anyway. Also, I did make a video about this not too long ago, but whether you have it plugged in or not, it does not matter. Not like a PC. Now a PC, I've actually tried it out. Doing inference on the PC makes a huge difference whether it's plugged in into AC power or not, but not on the Macs. All right, here we are, all set up to go, and let's go. Now Schwarzenegger is gonna have to wait till next time because there's just too many machines going on here at the same time.
Let's go!
And we're off, and you can see what's going on here. Right over here is a good example of what's happening. There's that memory pressure going up, and the GPU and GPU memory utilization is right there in that chart. And they all kind of look very similar. So the M2 Pro is not done yet. Still waiting for that one. It's taking a while. But the M2 Max and the M1 Max and the M1 Ultra are all done. Wow, it's done. 72. That's terrible. That's less than half of what these other ones can do. There's one very important thing to keep in mind also. The GPU core count, that plays a huge role in this. M1 Max has 32 GPU cores, the M2 Max 38. The M1 Ultra has 48, and the M2 Pro 19. Big difference. All right, second test, falling right in line here, just as expected. This is MobileNet. Ready? M1 Max got 415.7, M2 Pro 212.2, M2 Max 467.9, and M1 Ultra kicking some butt again at 634.4. Wow. Now I know some of you are going to be asking about this. During the training, the peak power for the whole package, that's CPU plus GPU, on the M2 Pro reached 23.72 watts. That's pretty low compared to the other ones. M2 Max reached 43.9 watts, that's pretty high. M1 Max reached 38.9 watts, almost as high as the M2 Max, and the M1 Ultra reached 59.72 watts. As for memory usage, with all the tests I ran so far, typically on the M1 Max, the M2 Max, and the M1 Ultra, memory pressure reached a comfortable 40% with GPU utilization nearly 100%. That's a very different story on the lower RAM M2 Pro, with memory pressure spikes going up to 80s and 90s, and an average of about 60%. The M2 Pro also showed the most amount of swap being used, but it really wasn't a significant amount. The M1 Max and the M2 Max also had a small amount of swap being used, and the M1 Ultra showed no swap at all. All right, we've got the results for the ResNet, MobileNet, Distilbert, and Bert Large. It's kind of what was expected, I suppose. The M1 Max did really well, as, you know, it should have. 64 gigs of RAM. The M2 Max is a nice improvement over that. The M1 Ultra still holds the crown because of the number of cores it has. The number of GPU cores is insane on that one. So that directly translates to faster iterations for the training. And of course, the M2 Pro, in my instance, has 19 cores as opposed to 48, and it did the worst by a long shot. Next, we're going to have a look at another TensorFlow example, but this time we're going to be training on the PC as well. So that one has the 3070 card, so we'll see how that does, and all these other machines as well. And we're going to see the difference between different batch sizes in this case. Also, we're using a different data set here. This is the CIFAR 10 database, and it consists of small images. Okay, let's go. Wow, that's 5 machines. So this is gonna run a little bit longer because it's got 25 epochs to run through. So it might take a little bit of time. And I am actually hearing the coil whine from that RTX board, even sitting about 2 feet away from it. Let's see if I can zoom in. Oh yeah, definitely making some noise. Now, we've already seen how the Macs behave. They're pretty much exactly the same across the board. The memory pressure is not as high on this test. We are using a batch size of 64 to start with. I will link to this project down below as well if you're curious. This is the first time I'm actually hearing the M2 Max be almost as loud as that PC. 3600 RPM. Holy cow. None of these other MacBook Pros are even getting close to that fan speed or that noise level. Here's the M1 Max at 2500, M2 Pro at about 1500, and this one is at 3500 RPM. And I can hear it. The fans are out there. Nah, it's still not as loud as the PC. Perhaps that loudness contributed to the fact that this thing finished first. Look at that, even the M1 Ultra is not done yet. None of these machines are done. One of them is done, the 3070 is done. But this one, also, the M2 Max. This first training has completed, and I am actually pretty impressed with the M2 Max here. So first, the M2 Pro came in last as expected at 539 seconds for that one. And the shocking thing here is that the M1 Max beat out the M1 Ultra in this case. M1 Ultra got 453 seconds and M1 Max got 443 seconds. But here's the surprise. The M2 Max got 327 seconds, which is considerably faster than all these other ones. And the RTX 3070 got 328 seconds, 1 second slower than the M2 Max. During this last and largest batch size run, the M2 Max reached a peak power of 55 watts. The M2 Pro 27.7 watts, 53.2 watts on the M1 Max, just a little bit lower than the M2 Max. And get this, 68 watts on the M1 Ultra. And of course, the RTX probably wants everyone to hold its beer, but it doesn't give the exact power usage in Task Manager, so that's just my guess. With a batch size of 1024, we got a bit of a switcheroo going on here. The M1 Ultra wins this one, comes out on top with 207. This time, the RTX 3070 gets a score of 240, which is a little bit faster than the M2 Max. That one comes in at 242. Then we've got the M1 Max at 297, and of course, the slowest one of the bunch, to be expected, the M2 Pro at 487. Our third and final test is going to demonstrate the Apple Neural Engine, and Peter Lin actually ran this on his MacBook Air, just to give you a comparison point before you see the results we're about to get.
So originally I ran it on the MacBook Air when I first got that. Got about 550 runs per second, which is pretty darn good. So for context, if we look at like YOLO model, which is one of the most popular models that came out 2017, 18, back then it was groundbreaking because you could do real-time inferencing on video. And that was doing about 60 to 80 frames per second. Before YOLO and before DenseNet, I mean, the fastest that people were getting were like maybe 3 or 4 frames per second.
Wow. Now, Peter also created this next test that we're going to do. This is using Core ML that Apple provides, and this is how we're able to tap into the Apple Neural Engine. Right now, it's pretty much the only way to be able to do that. But the improvements in performance and the power usage are incredible. His test was actually inspired by this other repo by Vladimir Chernykh. This is a couple-year-old repo. I'll link to the repo down below. You can go check it out. Peter's repo works on the new M2 and the M1 MacBook. So this is what we're going to be using right now. Every time we run this one, it's going to measure how many runs per second we get using the Apple Neural Engine, then using the GPU, and then using the CPU. So we're going to do it across all the machines except for this one. We don't need that one anymore. Thanks, RTX. You've served us well. Just the Apple machines this time around. Kick it off by just clicking this button, Start DenseNet. Now, while it's running, we can have a look at AziTop, and you can see the analytical engine is being used. Well, it was being used. It's very fast. I'll run this one more time for you so you can see. But now it's the GPU's turn. So the GPU kicked up. This tool right here doesn't show the neural engine being used. It's iStatistica. It's only showing the GPU and the memory and the relation between them. So that's good. That's why I'm running AziTop as well, so we can see the ANE being used. 709. That's pretty fast. And this is on the M1 Max, by the way. So we've got 709 for the neural engine compared to 105 for the GPU and 58 for the CPU. Now I'm going to run this one more time and pay attention down here to the ANE usage right here. Because as soon as I click that button, it doesn't take long. It's going to light up that neural engine real quick. Look at that. I'm going to click this and you'll see the ANE hop up there. It only reached 40% or so. Not sure why, but yeah. The GPU goes almost up to 100. Not quite. So that was on the M1 Max. On the M2 machines, the story is going to be a little bit different because they've improved the saturation for the GPUs and the scheduler has been improved as well. We'll have a look at that to see if that's actually true. That's what they said they did, but we'll see. During the run, the wattage remained extremely low here, even during peak ANE usage. With this neural engine, the performance per watt is really high, and that's what really sets Apple Silicon apart here. The saturation did show it was better on the M2 Max than the M1 Max by about 20%, with the neural engine hitting about 61% as far as this tool shows at least. So we do see improvement there, but it's not fully saturating quite yet. It still has more power, Captain. Was that a good Scottish accent? I don't think so. I want to see what the M2 Pro does here. ANE usage, 59%. So Yeah, that's as high as we get, I guess. Got a result for the M1 Ultra, so actually less than the M1 Max. RPS GPU is 99 and RPS CPU is 49. M2 Pro, wow. M2 Pro did pretty well here with 806 for the neural engine, 115 for the GPU, and 66 for the CPU. This is actually interesting. Even though the M2 Pro has a lot less cores, it only has 19 GPU cores as opposed to 32 of the M1 Max, it actually did a lot better than the M1 Max. And that is something I did not expect. And of course, if the M2 Pro did so well, the M2 Max did even better. 829 as the RPS for the ANE. RPS GPU is 124 and the RPS CPU is 67. Peter also added a couple of other tests here in the README. MacBook Air is here, 555 for the neural engine, 62 for the GPU, and 58 for the CPU. You can take a look at the repo for more information on this test. Are you subscribed to the channel yet? Consider subscribing. You'll see more tests like this, as well as other software developer things that we do and talk about here. And if you like this video, if you found it helpful, I'd appreciate a like. It helps me out. Thank you so much, and thanks for watching. I will see you next time.